Welcome back to the Learning Studio. You're watching our mathematics series, where we uncover the deepest ideas that power science, technology, and artificial intelligence. If this is your first time here, don't forget to follow us by clicking the link below. And remember, the complete playlist is also in the description so you can explore every episode step by step. Today, we're venturing into a field that takes mathematics from useful rules to absolute certainty. It's called real analysis, and it gives us the rigorous foundations of calculus and convergence. Let's go back in time. In the 1600s, Newton and Leibniz invented calculus. It was revolutionary, allowing us to study motion, change, and the forces of nature. But here's the problem. Their calculus worked, but no one was completely sure why it worked. The rules were powerful, but the logic behind them was shaky. Fast forward to the 19th century. Mathematicians like Cauchy and Weierstrass decided to rebuild calculus from the ground up. They introduced precision, rigorous definitions, and careful proofs. The result? Real analysis, the bedrock of modern mathematics. Core concepts explained simply. Here are the essential ideas you'll encounter in real analysis. Limits, the building blocks of calculus. Limits answer the question, what happens as we get infinitely close to a point? Without limits, derivatives and integrals wouldn't make sense. Continuity. A function is continuous if you can draw it without lifting your pen. Real analysis formalizes this idea with precise definitions, ensuring we know exactly when a function behaves smoothly. Convergence. Imagine an infinite sequence of numbers. Does it settle down to a single value, or does it wander forever? Convergence gives us the tools to understand infinite processes, critical for calculus, series, and even modern algorithms. Rigorous proofs. Real analysis doesn't just tell us that calculus works, it proves it, step by step. This rigor is what makes mathematics unshakable compared to guesswork. Why it matters in AI and technology. Now you might be wondering, why should someone interested in AI or machine learning care about real analysis? Here's why. Optimization algorithms rely on limits and convergence to ensure they reach the best solution. Infinite series underpin methods like Fourier transforms. Even the stability of neural networks depends on rigorous mathematical reasoning. Without real analysis, modern mathematics would be like building a skyscraper on sand. With it, we stand on rock-solid foundations. So real analysis is where calculus grows up. It takes us from intuition to certainty, from hand-waving arguments to bulletproof proofs. It's the discipline that ensures mathematics is not just useful, but unbreakable. In our next episode, we'll step into the world of complex analysis. If real analysis is about the real number line, complex analysis is about the mysterious plane of imaginary numbers, a world that turns out to be incredibly practical in signal processing, control theory, and even quantum mechanics. Don't forget to follow us by clicking the link below and check out the full playlist in the description. The deeper we go, the more fascinating this journey becomes.